Bismillahirrahmanirrahim. We'll continue dealing with 3.4. We did now the exponential function, logarithmic functions. We did these formulas, exponential functions and logarithmic functions for bases other than e. Now we'll go to higher derivatives. Now we can link higher derivatives with chain rule. Sometimes you don't need, sometimes you need. Okay, let me do the first one. Or, yeah, let me do example 11. This is a quick one. Example 11 is what? You have this function, x to the power 4 minus 3x squared, and he asks about the third derivative. So do the first, second, third, then substitute, which is nothing. That will be 4x cubed minus 6x. Second derivative, yeah, be careful with the calculation. That will be 12x squared minus 6. Third derivative, that will be 24x. So it will be third derivative add 2. That will be 48. So this is done. Nothing to worry about. Okay. Now, if we want to talk about the nth derivative. So I want to see the pattern. I think the first one in example 10 is easy one. What is e to the power x? What's the derivative? Same. Second derivative? Same. So what is the nth derivative? That will be e to the power x. Nothing to worry about. It's the same. If we do millions of derivatives, everything e to the power x. Okay, this is an easy one. Now we need to look at functions where I have pattern. You need to see what will happen to the function. So let me do the second one. Y equal 1 over x. Let me write it x to the power minus 1. Because usually we deal with the powers easily. Okay, y prime will be minus x is minus 2. Y double prime will be 2x is minus 3. Okay. The third derivative, be careful. Don't do the product. Just rewrite it. That will be minus 2 times 3x to the power minus 4. If you do the derivative, you will not see it. You will not see it easily. Because this is, I will deal with it as 3 factorial later. The fourth derivative, it will be minus times minus, that will be plus, so it will be 2, 3, 4, x to the power minus 5. Okay, now I think we can see the pattern. So let us try to figure out the nth derivative. We continue. What will be the nth derivative? Yeah, if I notice it, it will be, I have a number here. I have a sign here because it's minus, then plus, then minus, then plus. So there is a sign here somewhere, a sign here, and I have x to the power something. This will be the general format of the nth derivative for this function, which is x to the power minus 1. Okay. For the powers, I have minus 2 for the first derivative, minus 3 for the second derivative, minus 4 for the third derivative. So that I can write it minus n plus 1. So if I have first derivative, it will be minus 1 plus 1, which is minus 2. Second, if n equal 2, that will be minus 2 plus 1, which is minus 3, and so on. So this is the first things. Okay. Now let me check the number. The number is what? The number without the sign. Then I will talk about the sign. This is 2 factorial, which is 2 times 1. This is 3 factorial, which is 1 times 2 times 3. This is 4 factorial. It's very clear. 2, second derivative, I have 2 factorial. Third derivative, I have 3 factorial. Fourth derivative, I have 4 factorial. So this will be n factorial. Okay. Now the power. If you notice, if the derivative First derivative, odd ones, I'm getting negative. Even ones, I'm getting positive. So I will rewrite it, -1 to the power n. So if it is odd, 1 or 3, I'm getting a negative sign. If it is even, I'm getting a positive sign. So that will give me the answer. Yeah. So the idea, simply, is that you will do 3 or 4 derivatives and try to see the pattern. Try to see the pattern. Yeah. Sometimes he will ask you find the second derivative. I don't think you need to look for the pattern. You need to do it. Find the second derivative. Find the first and then find the second. When he asks you about the n derivative, then when he asks you like for the 50th derivative, you cannot do 50 derivatives, 1000 derivative. This is you need to look for the pattern. Okay, so in this one, what I will do, I need to find the derivative. So the first one, f of x, it's easy to write it as power. So what will be f prime? It will be -2, 3x minus 1 to the power -2. Don't forget this, which is times 3. So that is -6, 3x minus 2 to the power -3x minus 1 to the power minus. This is the first derivative. This is only the first derivative. Second derivative, do it the second time. That will be 12, 3x minus 1 to the power -3 times 3. And that is what? 36, 3x minus 1 to the power -3. Yeah. Okay, just calculation, do it 2 times. Second problem. F of x, now it's a product now. X squared e to the power x. Okay, we'll do it. First derivative of the first, 2x e to the power x, plus the first derivative of the second, which is e to the power x. Where I can rewrite it, 2x plus x squared e to the power x. Now, what I will do, I'll find the second derivative of this. Where I'll do the derivative again. Now I have product of 2 functions. So the derivative of the first, what's the derivative of this? It's 2 plus 2x times the second, plus the first derivative of the second, which is e to the power x. Now I have what? 2 plus 2x plus 2x plus x squared e to the power x, which is 2 plus 4x plus x squared e to the power x. Done. We found the second derivative for this function. Okay, third one, we'll do the same. What is the first derivative? Yeah. It's a product rule, function times function. Oh, let me write fx as usual. This is x sine x. So f prime, derivative the first one times the second, plus x derivative of the second. That will be the first derivative. Second derivative, be careful. This is cosine x. Here I have product rule. So that will be cosine x minus x sine x. So the answer is 2 cosine x minus x sine x. Yeah. If you ask about the second or third, I think it's good to do that. Do it step by step. No need to look for a pattern or something like this. Yeah, I think the idea is clear. Now let us go to the n derivative for different functions. Yeah, I have different functions. Let us look what will happen for these functions. First one, as we said, to find the n derivative, you need to start with, you do like 3, 4 until you feel that you understand what's going on. Huh? Then try to find the pattern. So I have f of x is ln x minus 1. What is f prime? 1 over x minus 1. It's better to make it as a power, so you can easily see it. F double prime, it will be minus x minus 1 to the power minus 2. Third, it will be 2, x minus 1 to the power minus 3. Fourth, that will be minus, as I said, don't do the product, times x minus 1 to the power minus 4. Yeah, I think we can feel the derivative. If you want, you can do the fifth one, just to be sure. That will be 2, 3, 4, x minus 1 to the power minus 4. Now, what will be the nth derivative? As usual, let me do a different color. So I have sine, they have a number, and they have x minus 1 to the power of something. That will be the format of the n derivative. Let us try to find these ones. Okay. The power, first, minus 1, second, minus 2, third, minus 3, fourth, minus 4, fifth, minus 5. So it will be minus n. Easily to see it. Now, the numbers, I have here 2 factorial. Right? So I have 2 factorial for the third, 3 factorial for the fourth derivative, and 4 factorial for the fifth derivative. So it means what? N minus 1 factorial. Okay, now the power. For the even, it's minus, and for the odd, it's positive. In the previous one, it was for the even, it's plus, and for the odd, it's negative. Now it's the opposite. For the even, it's negative, and for the odd, it's positive. So I have minus 1 to the power n plus 1 or n minus 1. Both will work. So for the odd, so for example, the third one, it will be 3 by plus 1, so minus 1 to the power 4, which is positive. For the even, 4 plus 1 will give me a negative value. Okay, that will do this one. Now, let me go back to the second one. I'm starting with e to the power 2x. Okay, first derivative. That will be 2 e to the power 2x. Okay. Second derivative. Yeah, be careful here. Actually, it's e to the power 2x. Let me do it this way. E to the power 2x times derivative of u, which is 2. Huh? So it's 2 e to x. Now, second derivative, this is 2 times. I'm doing it in details. Derivative of this, which is e to x times 2, which can write it 2 square e to x. Yeah, if you notice, I can now use the square, the power. Third derivative. Don't write it 4. Make it in this format. So it will be 2 square derivative of this times 2. So it will be 2 cubed e to x. Yeah, now I can see the pattern. The fourth derivative will be what? It will be 2 to the power 4 e to the power 2x. So what is the n derivative? The n derivative, very clear. It will be the format of this. There is 2 to the power of something, e to the power of 2x. Yeah, and what is that? For the first, it's 2 to the power 1. For the second, 2 squared. For the third, cubed. The powers, huh? For the fourth, 4. So that will be n. So it's 2 to the power n, e to the power 2x. Yeah. As I said, the idea is that you need to do 3 or 4, sometimes 5. It depends the way you look at it. And then you try to figure the pattern. Trig functions. I think we did something like that in 3.3, but now I have cosine of a value. Cosine of 2x. What shall we do? Okay. He want the fifth derivative. Actually, he want the end somehow. You need to see the pattern. Okay. For the trig functions, if you remember before, the idea is that every 4 times they will repeat themselves. So I need to do at least 4 until I see the repetition. Also, I need to see what is the effect of these two, of this value. So let me start cosine 2x. What will be f prime? It will be sine 2x minus sine 2x, sorry, times 2. In other words, you need to be careful. 2 times minus sine 2x. Okay. The second derivative will be 2. Now, what's the derivative of this? This is minus cosine, sorry, minus cosine 2x, derivative of the 2x, which is 2. So you have 2 square times minus cosine 2x. I'm doing it this way. I will tell you why. The third derivative, that will be 2 square, derivative of this, which is sine 2x times 2. So I'm getting 2 to the power 3 sine 2x. The fourth derivative, that will be what? 2 cubed, derivative of this, which is cosine 2x times 2. So I'm getting 2 to the power 4 cosine 2x. Notice this is what I'm starting with. I'm getting it now. But times a number. Times a number. Okay. Now, if I want to think about the n derivative, well, let me say you want what? The 50th derivative, the 50th. Okay. Before that, let me think about what's going on. Let me check what's going on, if just something to notice. Okay. I have two things. I have the number. And I have the function. And the function going this way, the function, without the number, huh? It will be cosine 2x minus sine 2x minus cosine 2x sine 2x cosine 2x times the number, huh? I don't the number, we'll talk about it later. Because of that, I do it this way. So this is f prime, f double prime, f triple, f fourth. Now, what they want the 50th derivative. Okay. So as a function, it will repeat itself every 4 times. It will repeat itself every 4 derivatives. Times the number, then we'll look at the number. So now, the 50th derivative, if you think about 50 divided by 4, that will be 12, 48. This is 2. So as a function, the 50th derivative is similar to the second derivative as a function, but not as a value or as a number. So this one, I'll take this function, which is minus cosine 2x, because it's going this way. Cosine 2x minus sine 2x minus cosine 2x sine 2x cosine. So the second derivative will be this one. This is similar to the fifth derivative. As the number, it's 2 to the number 1, 2 to the power 1 for the first, 2 to the power 2 for the second, 2 to the power 3 for the third, 2 to the power 4 times. So we have 2 to the power 50. 2 to the power 50. So this is my answer. It will be minus 2 to the power 50 cosine 2x. So we need to think about two things: how the function is changing and how is the number as a power changing. Okay, I wish it's clear. Now let me do another problem. Yeah, this is, I think, easy one. We'll try to figure it out. What will be f prime? It will be, I have product rule, derivative of the first, 1 times e minus x plus x, let me do it in details, minus e minus x, because I need the chain rule. And this one, it will be e is minus x times the derivative of this, which is minus 1. So I'm getting what? 1 minus x is minus x. Okay. Second derivative will be what? Now we'll do the product rule again. Derivative of the first, which is minus 1 times the second, plus the first. Derivative of the second, we did that before, minus e is minus x. So if I want to simplify it, I have minus x times minus 1, that will be x. I have minus 1, x minus 2 is minus x. Okay. Third derivative, that will be what? Now I do the product rule again. That will be 1 times e is minus x plus x minus 2 times minus e is minus x. So that will give me, the number is 1 minus 2 times minus 1. That would be 3 minus x is minus x. So I think it's very clear what will happen to the fourth derivative. Fourth, it will be x minus 4 is minus x. Okay. So if this is, the power is even, it's x minus the number times e is minus x. If the power is odd, it will be the number minus x. That e is minus x. I think it's very clear. So what will be the 1000 derivative? It's an even one, so I'll follow the even, which is like 4 and 2. So it's x minus the number. Now the number is 1000. E is minus x. So that will be my answer. Okay. Yeah, this is the question when it's related to the differential equations. But I think the idea is very clear. He gave you y. You want you to find r satisfying this. So what you will do, there is, I think, one question in the book. Y prime, it will be r arx. Y double prime, it will be r square arx. I need the chain rule, e to the power u, which is e to the power rx times r, and e to the power rx derivative, which will be e to the power rx derivative of this, which is r, since r is just a number, times r. Now I'll plug this into the equation. So I have y double prime minus 4y prime minus 5y. That give me what? R square arx minus 4r arx minus 5 arx. That should equal to 0. In other words, I have r square minus 4r minus 5 arx equals 0. I know that the exponential function never be 0. E to the power a value, this is never be 0. So that means r square minus 4r minus 5 equal to 0. So I have what? R minus 5, r plus 1 equals 0. Yeah, so it will be, minus 4. Okay, correct. So r equal 5 or r equal minus 1. That will be the answer. Now we'll go to the old exams questions. I think we did that before. Let me do it again. He won't have this function, and he wants the 100 derivative and 101 derivative. Okay. Yeah, you need first to think about this function. I cannot multiply x plus 1 50 times. But if you look at it, this is, what is the highest power I will get? It will be 2 times 50. That's the highest power I will get. So I have x to the power 100. X to the power 100. Plus, this will be the highest power I will get. Plus a value times x to the power 99. Plus another value, another constant, times x to the power 98. plus blah, 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 plus, what do you call it? Call it A1, A2, until I get A100, something like this, a constant. So this is my function. If you remember, we said if I have x to the power n, what is the nth derivative? That will be n factorial. What is the n plus 1 derivative? That will be 0, because this is the number. The next derivative will be 0. n factorial is just a number. Okay. Now, if I want to find the 100 derivative of this function, yeah, let me think of it this way. For this one, x to the power 100, I have the same power. So I have f of x, let me say g of x. Think of it this way. G of x, x to the power 100. What is the 100 derivative? 100 derivative of that function, x to the power 100. And I want the n derivative. That will be 100 factorial. So the derivative of this, the 100 derivative of this, give me 100 factorial. Okay. Now, if I have h of x, x to the power 99, what will be the 100 derivative of this one? I have x to the power 99, and I want to get, if this is 99, this is 99 plus 1, the 100. This is 99 plus 1. So what will be the result? 0. So the derivative here will be 0, 0, everything will be 0. Since I'm doing the 100 derivative of that. So now what will be the 100 first derivative? Since this is just now, let me finish it. That give me what? 100 factorial. This is are zeros. I don't have x. So it will be 100 first derivative. It's just a number. The derivative will be 0. So my result will be what? 100 factorial. 100 factorial minus 0, which is 100 factorial, and that will be my answer. Okay. Minus x e to the power x. I want the 51 derivative at 1. The 51 derivative at 1. We did x e to the power x. And then x is minus x. That will be easier. Now let us see what will happen. See the pattern. It's just a minus sign. I can't throw it away. Huh? F prime will be, let me do the calculation. Who cares? This one will be minus 1 e to the power x. Okay, consider this is the first, this is the second, plus the first times the derivative of e to the power x, which is the same. That give me what? Minus 1 minus x e to the power x. Okay, that give me minus 1 minus x e to the power x. Okay, second derivative. Second derivative will be what? Derivative of this minus 1 e to the power x plus this times derivative of this e to the power x. So it's what? Minus 2 minus x e to the power x. Third derivative. Derivative of this, which is minus 1 e to the power x, plus this derivative of this e to the power x. So it's minus 3 minus x e to the power x. Clear? What is the n derivative? Very clear. It will be minus n minus x e to the power x. Now what he want? He want the 51st derivative. That will be minus 51 minus x e to the power x. I want this at x equal 1. So that will be minus 52 e to the power 1, which is e. So this will be my answer. X e is minus x. I think we did. Yeah, we did it here. Let me write what we did, and now try to figure it in one format. X is minus x. The first derivative, if you remember, it's 1 minus x is minus x. The second, x minus 2. The third is 3 minus x. The fourth, x minus 4. Okay. So I have it. If it is odd, it will be in format x minus n. If it is even, n minus x. But I don't. He wanted the n derivative for any n, either odd or even. I can do this trick. This one, 1 minus x is what? Minus x minus 1. Yeah, it's minus x plus 1, which is the same. So this one, I write it minus x minus 1 e to the power x. And I write this minus x minus 3 e to the power x. So what will be the n derivative? Now I can write the n derivative. Because it will be what? X minus n e to the power x e to the power minus x, sorry. Minus x. E to the power minus x. Because I have x minus 1, x minus 2, x minus 3, x minus 4. There is the minus sign here. Minus, plus, minus, plus, minus, plus. So I will do it with minus 1 to the power. For the odd is negative, for the even is positive, minus 1 to the power n. Now I write it in terms of n. Okay. Now what they want? They want the n derivative at 0. So if I have x equals 0, what will happen? So I have minus 1 to the power n. So I have minus 1 to the power n, 0 minus n, so it will be minus n, e to the power 0, which is times 1. So actually it will be minus 1 to the power n times minus 1 times n, which is minus 1 to the power n plus 1 times n. So that will be my answer. Okay. X e to the power over e to the power x. Yeah, you can think of it. X is minus x. That's it. Like what we did before. Actually, like what we did also in this case. It will be easy to figure it out. So what they want the 100 derivative, 101st derivative. So the odd ones. Look at this one. The odd, give me the number minus x. The odd ones, because 101st is an odd one. Or you can do it again. So I have 101 minus x is minus x. Now just substitute. What they want? They want this at x equals 6. That will be what? 101 minus 6 is minus 6, which is 95 is minus 6. And that will be the answer. Yeah. The same thing, but he wants it at 0. The same thing. Yeah. X is minus x. We say the 100 derivative. It would be 101 minus x is minus x. Now I want it at 0. So it will be 101 minus 0, e to the power 0, which is times 1. So that will be 101. That will be the answer. The n derivative, I think we did that before. We did it before. Which is this one? The same question again. Now we'll move to cosine. Cosine and sine. Yeah, we'll do problems related to sine and cosine. Then to go to 1 over x. And then we'll stop. Okay. Yeah. Cosine x. Now, what will happen? We know that. Actually, we did that in the 3.3. It's okay. F prime minus sine. F double prime minus cosine. The third sine, the fourth cosine. So now this is a repetition of what we started with. So it will be the 42 derivative. 42, if we divide by 4, you get what? 10, 40. The remaining is what? 2. So this is the same as the second derivative. And what is second derivative? Minus cosine x. What I want the 42 derivative at 0. So it's minus cosine 0. Cosine 0 is 1, so that is minus 1. That would be my answer. I have sine plus cosine. Okay. Let us see the button. Sine x plus cosine x. You can do it one by one, or you can, in this problem, you can do it at the same time. Minus cosine, minus sine, I mean. That will be minus sine, minus cosine. Third, it will be what? Minus cosine plus sine. Fourth, it will be sine plus cosine, which is the one I started with. Okay. Now it comes to 2019. If we divide by 4, the remaining is 3. 2020, if we divide by 4, the remaining is 0. So that means the 2019 derivative will be similar to the third derivative. And what is the third derivative? Is this one. Minus cosine x plus sine x. What they want it at pi. That will be minus cosine pi plus sine pi. Cosine pi is minus 1 times minus. That sine pi is 0. Minus 1 times minus. That will be 1. Okay. Now let us do the 20th derivative. 2020 derivative. It will be like the 0 or the 4. It's the same. So that will be sine x plus cosine x. At pi, that will be sine pi, which is 0, cosine pi minus 1. That will be minus 1. So what is the 20th derivative? At pi minus the 20 derivative at pi. That will be 1 minus 1. So the answer is 2. That will be my answer. Now if I have cosine 5x, remember, we did something similar, which is cosine 2x. So you need to be careful where I have a number and the function. The function going in every 4 times, it will repeat itself, but the number, it will 2 to the power 1, 2 to the power 2, and so on. So let us do it, but be careful with the calculation. Okay, so cosine 5x. What will be f prime? It will be 5 minus sine 5x. Second derivative, if you remember, we can do it, 5 square minus cosine 5x. If you differentiate this, you need to multiply by 5, multiply it by here. So I think you can do it like what we did before. That will be 5 cubed sine 5x. The fourth, it will be 5 to the power 4 cosine 5x. Now this repeats itself. Don't forget I have a power. I have a number. Now what I want, the 27. 27 over 4, it's 6, 24. So it's like the third one. So 27 at x will be what? The third as a function. But the power will be 5. The third, 5 to the power 3. So this is 5 to the power 27. Times the function, which is sine 5x. What they want, that's what they want. And this is my answer. Okay, now we divide by a number. Okay, let us see what will happen. Now, let us see what's the first derivative. The number is nothing, huh? Just you take it away. 1/2022. This one is what? Let me do it carefully. Minus sine 2022t times derivative of this, which is 2022. So actually, I'm getting what? Minus sine 2022t. This is my first derivative. Second derivative. Now the number will come. This will be minus cosine 2022t times the same number. This one to the power of 1. Third derivative. Now, derivative of this, which is sine 2022t. I need 2022 times this. I have 2022 squared. The fourth derivative will be what? Cosine 2022t, which is the same one I started with, times 2022 to the power 3. Be careful. The power before, it was the power similar to this. Since I divide by this number, so the power is less by 1 point. Okay. Now what they want? They want 2022 derivative. 2022, if we do by 4, actually I need to care about this. I have only 2. This is the remaining. So as a function, it's similar to the second as a function. So I have minus cosine 2022t. As a power, this is the 2022. I have the second, I have to the power 1, the third to the power 2, the fourth to the power 3. So this will be 2022 to the power of 2021. Okay, so I have minus 2022 to the power 2021 times cosine 2022t, which is this one. Sine square. That's sine square now. Okay, let us see what will happen. Sine square x. Okay, what will be f prime? F prime will be 2. Its function, something is square. So it will be, it is sine x all square. So it will be 2 sine x, derivative of sine x, which is cosine x. You need to figure out or to remember what is this. This is sine 2x. Now we are done. Now I can see the button. So the second derivative, I'm starting with this. So it will be what? Cosine 2x times 2. The third, it will be minus sine 2x times 2 times 2, 2 square. The fourth will be minus cosine 2x, 2 to the power 3. The fifth will be what? Sine 2x, 2 to the power 4. 2 to the power 4. So this is what I start with the f prime. I'm getting this. So this is the repetition. Okay. So now when it comes to the 100 derivative, that will be what? 100. It will be like the fourth. 100. Yeah, if you divide by 4, you get 0. So it will be like the first. I did not start with the button. The button started from here. So 100. It's like the fourth one, but I need to think about the power. 2 with the second is 2 to the power 1. With the third is 2 to the power 2. So there is one point. So this will be 2 to the power 99 times the function, which is minus cosine 2x. Now substitute. You want it at what? At 0. Cosine 0 is 1, so that will be minus 2 to the power 99. Okay, 1 over x, I think we did before. Yeah, 1 over x, I did it here. So this is the end derivative. What they want. Yeah, let me write this, what we did before. So the fn derivative is minus 1 to the power n, huh? Blah, blah, blah. Where is it? Where is it? Where is it? Where is it? N factorial x to the power minus n plus 1. Yeah, I can't do it again. That's okay. N factorial x to the power minus n minus 1. What they want? They want the 50th derivative. That will be minus 1 to the power 50. So n is 50. 50 factorial times x to the power minus 50 minus 1 minus 51. So this is plus. So this is 50 factorial x to the power minus 51. They want this at my x equal minus 1. So that will be 50 factorial. Minus 1 is minus 51. This is a negative value. Minus 1. So it will be minus 50 factorial. So this is will be my answer. Okay. Now 1 over 1 minus x. Yeah, let us do it. And also we have this. Then we have this. Okay. Now let us see the pattern. 1 over 1 minus x. I will write it 1 minus x to the power minus 1. Okay, first derivative. See the pattern. It will be minus 1 minus x to the power minus 2. Don't forget derivative of this, which is minus 1. So that I'm coming back to minus x to the power minus 2. Second derivative. That will be minus 2. 1 minus x to the power minus 3 times minus 1. Derivative of this. So I'm getting 2. 1 minus x to the power minus 3. Third, if we do the calculation, you will get what? 2 times 3, 1 minus x to the power minus 3. You can't do it. Let me do it here. That will be 2 times minus 3, 1 minus x to the power minus 4. Derivative of this, which is minus 1. That will retain it plus. Fourth derivative, just to be sure, that will be 2, 3, 4, minus 5. So what will be the end derivative? The end derivative, I don't need a sign. All of them is positive. So I have x minus 1, fourth minus 5, third minus 4. So it will be minus n minus n minus 1 or minus all n plus 1. So the third, it will be minus 4. The fourth, it will be minus 4 plus 1 minus 5 and so on. Times the number, it will be n factorial. The number is n factorial. Okay, this will be the number. All right. Yeah. Oh. Sorry, this is not x minus 1. This is 1 minus x, sorry. This is, I'm writing it 1 minus x, 1 minus x, 1 minus x. That should be 1 minus x. So this is 1 minus x. Yeah. Now, what is the 2018 derivative? That will be, the n is 2018 factorial, 1 minus x to the power minus 2019. Okay, now if you want to find it at 2, that will be 2018 factorial, be careful, 1 minus 2 to the power minus 2019. This is odd. So the minus sign will make a change. This is minus 1. So that will be minus 2018 factorial, and that will be the answer. Okay. Now it's 1 over 2x plus 3. Yeah. So y is 2x plus 3 to the power of minus 1. Be careful now with the calculation. Y prime will be minus 2x plus 3 to the power minus 2, derivative of this, which is 2. Y double prime, what? Minus, that will be 2x plus 3 to the power minus 3. This is a number, will remain, times derivative of this, times 2. Just to show you what will happen. The third derivative, it will be 2 minus 3, 2x plus 3 to the power minus 4. This number will continue. Derivative of this, times 2. Yeah, now we can see the pattern. I have 3 things. I have this. I have 4 things, actually. I have the number. I have the sign, because minus plus. I have this one, and I have this one. So I have 4 things to find the end derivative. Let me see the fourth. That will be 2 minus 3 minus 4 2x plus 3 to the power minus 5. This the number will continue because it's just a number. Derivative of this times 2. Okay, now if you want to think about the end derivative, that will be what? Yeah, I need that x. It's okay. So this, let me do this. This will be 2x plus 3 to the power of something. This one, very clear, I have 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So it's 2 to the power something. Here I have what? You have 2 factorial. Here you have minus 3 factorial. Here you have 4 factorial. So I have something factorial. And I have the power. Now I need to figure out what will be these numbers. Here, for the power, this is the easy one. The first one, 2 to the power 1. Second one, 2 to the power 2. Third, 2 to the power 3. So that this is 2 to the power n. Okay, the power of this expression, 2x plus 3 to the power minus 5. So the third minus 4, the fourth minus 5. So that will be, let me do it, minus n plus 1. Okay, the factorial. Third factorial. Fourth factorial. So I have n factorial. Now for the even, it's plus. For the odd, it's negative. So it's minus 1 to the power n. Like what we did before. Now what they want? They want the 63 derivative. That will be what? The n is 63. Then I will substitute minus half. That will be minus 1 or 63. Okay. 63 factorial. 2x plus 3 to the power 63 minus 64 times 2 to the power 63. Yeah, this is what I get. Okay, now I need to substitute at minus half. Actually, I substituted here. So let me do it easily here. If x equal minus half, 2x plus 3 will be what? Minus 1 plus 3, it will be 2. It will be 2. So that will be minus 1 to the power 63, which is minus 63 factorial. Here we say this is 2. So times 2 to the power minus 64 times 2 to the power 63. What is this? This is 2 to the power minus 1. So this will be minus 63 factorial over 2. Because this is 2 to the power minus 1. Yeah, we get the answer, which is this one. Okay. Yeah. Let me go to the last one in this part. X ln x. Have product of two functions. So let's see what's f prime. Product of two functions. The first derivative of the first is 1 times the second plus x, derivative of ln x, which is 1 over x, which is actually 1 plus ln x. So it will be the second derivative. It's 1 over x, which we know how to do it. The third derivative, but the pattern will start from here. It's okay. Minus x is minus 2. The fourth, the fourth, just to see the pattern, it will be 2x minus 3. The fifth, it will be 2 times minus 3, x to the power minus 4. The sixth, just to see it for sure, 2 minus 3 minus 4, x is minus 5. So it will be the end derivative. I have x to the power something in terms of n. Here I have something factorial, and I have minus 1 to the power something. To the power something here. Okay. Now let me see what are these things. Okay. So the third minus 2. Fourth minus 3. Fifth minus 4. So that will be minus n minus 1, n plus 1. N minus 1, sorry. So the fourth, it will be 4 minus 1, 3 minus 3. The fifth, 5 minus 1, 4 minus 4. Working fine. The factorial, I have here 2 factorial. Here 3 factorial times the minus sign here. I have 4 factorial. So it will be n minus 2. The sixth, I have 6 minus 2 factorial, which is 4. The power for the even, it's plus, for the odd is negative. So this is minus 1 to the power n. What they want 61. That will be minus 1 to the power 61. 61 minus 2 times 59 factorial. X to the power minus 61 minus 1 minus 6. Now what they want this at 1. So this is negative. So I have minus 59 factorial. 1 to the power minus 60 times 1. So it's minus 59 factorial. That's it. So I think we did a good number of questions about this higher derivatives. Let me stop. And then I will continue later. Okay, let me stop the recording. Thank you.